Welcome to Cow Talks. I'm Chris Pravat, Beef Cattle and Forage Commodity Director for the Alabama Farmers Federation.
And I am Marcelo Valau, Forage Extension Specialist with the University of Florida.
And this is our podcast, where we dive deep into the main topics affecting livestock and forage production in the southeastern United States.
From the mainstream media to new technologies straight from our research stations.
From cattle prices to international trade.
From our pastures and beyond.
Join us on this journey as we tackle the main issues affecting our producers and the sustainability of our production systems.
I'm Marcelo Valau, Forage Extension Specialist, and with me, my beloved co-host, Chris Pravat.
Great to be here. Exciting topic today. It's definitely something we need to be talking about, need to be understanding a little bit more.
You bet. So our topic today is about the new world of screwworm, which is making headlines in many of our news today and also causing a lot of concern in our commodity groups, livestock, but also wildlife. With me today is Dr. Andrew Schwartz, the chair and professor with the UF IFAS Entomology and Hematology Department. And he also is coordinating the Screwworm Task Force at the University of Florida. And Dr. Ted Burgess, which is an assistant professor of veterinary entomology, who focuses mainly on the management of insects in livestock, specifically on flies in livestock. Welcome to the Cow Talks podcast.
Yeah, thanks for having us.
Thank you. Great to be here.
So I thought we could start with a little bit of a background of what is this threat, what is this screwworm, and why it's such a big threat for us.
So it's a really unique fly pest of livestock. So this is a non-biting fly. This is not going to be like a horn fly or a stable fly. This is going to be much more like a house fly. Has the same type of mouth part. So they don't bite and blood feed on the animal. The adult fly doesn't blood feed. But what's unique about them is they belong to a group of flies that are widely characterized as necrophagous flies. So they will lay their eggs in things like roadkill or dead animals, carrion, things like that, and the larvae will develop in that type of environment. The New World screwworm is unique in that it's primarily colonizing live tissue. And that's where it becomes a huge risk to livestock production. The females will lay their eggs around little wounds or really any kind of open wound, but wounds as small as a tick bite. And those eggs will hatch, and then those larvae crawl into that wound and start to eat the live tissue of the animal. And so that's where we really start to come into the huge risk and the unique aspect of this fly from pretty much every other type of fly that cattle producers are going to be dealing with.
I think one of the important things is unlike other flies that you might be familiar with like bot flies and things like that. One fly is going to lay several hundred eggs. So you're not going to have one maggot in this wound. You're going to have 300 maggots in this wound, and then that's going to attract more females to lay more eggs, and then you're going to have 300, then you're going to have 1,000, then you're going to have just this expanding kind of wound necrosis, which can eventually kill the animal.
So pretty quickly, it really makes a big mess and gets to a big problem. What is the cycle time frame that we're looking normally?
So females will lay their eggs. The eggs will hatch somewhere between about 12 and 24 hours. Insects are ectotherms, so they're highly dependent on the external temperature that they're in. And so these ranges that I'm going to give, you can find a lot of variable information out there, and a lot of that really has to do with temperatures. So the egg hatches around 12 to 24 hours after it's been laid, and then first stage larvae move into that wound, and they start to feed with their head down. They breathe through their posterior end, and then they continue to feed downwards in the animal, kind of going deeper and deeper into tissue. They will develop into a second instar or a second stage larvae, and then a third stage where they will eventually climb out of the wound. They'll wriggle out of the wound, void their gut. So they're basically just a hollow larvae, and they fall into the soil and burrow in the soil. And those larvae take about 5 to 7 days to develop in the animal. And then those larvae will burrow just under the surface of the soil, and that makes them very hard to find because they're kind of hidden from sight. And then that next stage is called pupation, where they kind of encapsulate themselves in something kind of akin to a cocoon from a butterfly, and it'll take anywhere from 5 days all the way up to 50, 60 days depending on the temperature of the soil. And then those puparia, the developing fly inside that puparia, will pop the top of that puparia off and climb out, and then that's an adult. And then it takes a few days for them to become sexually mature and mate, and then the female goes and finds new hosts.
Yeah, so like you're basically looking like this time of year, which is kind of like the peak summer, like which is when they're going to develop the fastest. We're looking around a 3-week turnaround from like egg to egg, so from complete life cycle. But as Ted's mentioning, like in the cooler months, it can take several months. That's kind of why right now is a bad time to be having an outbreak, because this is the time when their life cycle is going to be the fastest.
But also the other side is the life cycle is fast. On the other side, it also can stay there in the soil.
Diapause, yes.
Diapause.
Diapause, yes. It can stay in the soil for a long time, and if the soil goes below about 45 degrees, it will kill it. It will temperate climates will have some control that way. But as long in areas where the soil doesn't freeze like that or get that cold, then they could go long periods of time.
I want to understand this is not a new thing here. Actually, I grew up with screwworm in southern Brazil. Has a tremendous impact livestock. I remember when we're dropping flies when I was a kid. I remember the cartons of flies never went anywhere. So it's a reality for us every year there. And it is also not new here in the United States. What's the history of the problem and then the eradication?
Sure. Basically, screwworm is originally endemic to all of South America, Central America, the West Indies, up into South Texas and the American Southwest. It didn't actually originally occur in Florida or anywhere east of the Mississippi River. So that's its native range. So in Texas, it's a native species originally. So it's been a pest species for a long time. It got into Florida in 1933 by livestock movement. So it wasn't actually a pest in Florida until the 30s. Even within Florida, it doesn't occur everywhere all the time. So basically what's happening here is peninsular Florida. It occurs throughout mostly all the year round, and then it will seasonally migrate out into the rest of the southeastern United States from there. And so it was a problem for a long time and caused significant damage to the industry at the time. There was an eradication program, some biology was done to basically found out that these flies only mate one time. And so the females only mate once. And what that means is if you can basically mate that female with a male fly that is essentially infertile and is not producing viable eggs, then that will just terminate the life cycle and will bring the flies under control. And so that technology was developed throughout the 40s and 50s. And basically they mass rear flies, they irradiate them, doesn't kill the flies, but makes them sterile. They release millions and millions of these flies. They mate with the wild flies, no more offspring, kills off the populations. So they trialed this. This technology was actually first trialed in Florida in the early 50s. Then it was tried in the Caribbean. They demonstrated it worked. They started eradicating in Florida in 1958. It took 2 years. They eradicated it from the entire state, from the entire Southeast. Basically, by 1960, it was completely eradicated from the Southeastern United States. Then they did the same thing in Texas, eradicated from the U.S. in 1966. And what happened then was, even though they eradicated it from the U.S., you still had these problems where it would seasonally migrate up from Mexico. And so it would continually reinvade the United States. And so what they did then, they decided, okay, we need to push this away from the border so we're not under constant threat. And so they pushed it down first to the Isthmus of Tehuantepec in Mexico, the narrowest part of Mexico there, just above the Yucatan. And that's both so it was pushed away from the U.S. border, and also that very narrow space means it's much more economical and easier to release flies across a very narrow space as across the entire southern U.S. border. And so that's what they did, and they eradicated it down there. And then they decided, hey, why don't we push it all the way down to the narrowest part of Central America, down in Panama? And that's what they did. They accomplished that in 2001, and it's been restricted to south of Panama for the last 25 years.
So very, very interesting history of the eradication and how it worked. What happened now that if we were able to move it down, what happened now that it's became a threat once more?
That's a good question. So there's a lot of speculation on that right now. It's and I think that's still an ongoing question that needs to be answered. But what we do know about it is that it has made its way past that quarantine zone, and it is starting to steadily make its way back up through Mexico. And what was it, as of just a couple days ago now, it's about 350 miles from the Texas border. So it's rapidly making its incursion northward again.
Yeah, I think in 2022 they first started getting cases in Panama that were beyond the barrier zone, and it kind of simmered for a while, and then it kind of advanced into Costa Rica, and then in less than a year ago, actually last November, it was found in Mexico for the first time, and that's when it first broke into the news and kind of triggered the first of now three, border shutdowns. Right around the time the first border shutdown happened, this is when it was first picked up in Mexico and caused like the first little freak out that it might be getting a little bit out of hand. And then they kind of brought things a little bit under control, but it was still spreading in southern Mexico. Just a month ago, it was spreading up further north. You can see it kind of up and now into the now it's kind of widespread in southern Mexico and getting up and just beyond like southern Oaxaca there, just kind of getting in, just still at the narrowest point. And it, for the last 2 months, it's been more or less this state. There is not, it kind of was stabilizing until just basically now. You can see there's a point now that's up on the coast of the Gulf, and that's basically now jumped like 200 miles closer to the border, and that is really cause for concern, both because it's closer to the border, but it's really moved out of that very narrow part of Mexico, and now it's into the much wider part of Mexico. And that is not good news, because it is much harder to, when it reaches that much broader space, that much wider space, that means the effort and the amount of flies needed to control it are significantly higher, and our capacity to do that is very limited right now. And so, yeah, it's not great news.
I want to talk a little bit about the border closure and what it means and all that. But before, it has not made to United States yet, right?
Correct.
Okay. But we had issues before. There was an outbreak in Florida that was controlled. So we're still able to manage that. There was an outbreak in
the Keys, the Florida key deer. Yeah.
They used the sterile fly technique on this. There was still capacity, and the facility in Panama was sending flies to Florida to get that under control. We had the benefit of it being in a not super highly populated area, and an area where there aren't a lot of livestock, which is why it was primarily the key deer that were in the news on that. But it was also found in wildlife as well, and even in some companion animals, cats and dogs. I think that's an important thing to distinguish here as well, as this isn't strictly a fly that targets livestock. This is going after living organisms. We find it, because of the intensification of livestock production, that it can have a great effect on that. And we also, it's in the spotlight because there are tremendous economic conditions that are involved with that. But, it's not a fly that is specific to livestock. We find it in wildlife. Rarely it will be found in humans. It's not a specific livestock only fly, and so that also challenges our ability to do control on it.
I think that's a really important point that Ted just brought up, is that this is not a livestock only pest. And so it's going to be, it can occur in any warm-blooded animal. I mean, in theory, it does occur in birds, but that's very rare. But it's going to any kind of large animal, so hogs, deer, raccoons, dogs, all that stuff, sometimes rarely people, that can occur in as well. And so I think it's important to remind you, you can inspect every single cow coming across the border or in an area or on a farm. That doesn't mean that area doesn't have screwworm, because it can be in the deer, it can be in other animal populations that are completely unregulated or that are just moving around naturally. And so I think that's a really key point in all of this, and why even if the border is completely tightened up with livestock movement, that does not itself mean that it cannot come in.
So I guess what we're talking about from 2016, 2017, the Florida case, that was from the Caribbean, where it already is endemic in Cuba, in Haiti, in the Dominican Republic.
I would say there is no determination of where the Florida Keys outbreak came from. Officially, there's no, it is unknown origin.
Okay. Why? Is it because of the barrier, from the Gulf, from the ocean there? Is that the reason we don't see more cases?
That's exactly right. The fact that the one of the reasons it's been speculated it was not native to the eastern U.S. originally is because it could not cross the Mississippi, so that it does not do well crossing large bodies of water. So that's to our benefit as well, and that's also why the Keys outbreak was almost like if you were going to have an outbreak, it's ideal case. Put it on an island away where you have one road going in, it can't get anywhere without kind of some kind of facilitated movement. So yeah, it's obviously it's been in Cuba it was never eradicated from Cuba, and we don't have
Yep.
problems all the time coming in from Florida, and it's not that far away. So yeah, you're absolutely right. It's not, the water makes it a good barrier.
Yep. And then you mentioned the birds too, which that is a great benefit that we don't have many screwworm issues with the birds coming across.
Yeah, no, can you imagine like birds with like flesh eating maggots just kind of like flying around everywhere? Yeah, no, thank God that's not the case.
So we woke up today to the news of another border closure. And I'm going to start with Chris. What does that mean there? What does it mean, especially from the economic side? What is important there?
Yeah, so a lot of feeder calves come from Mexico into the United States each year. It's a big deal. There's concerns on both sides. Where do they go with all these feeder calves? Mexico, they don't have the feedlots. They don't have the packing capacity for those cattle. And then the cattle feeders that are just on the other side of the border that typically get those cattle, obviously they have open pens. So if you're a feeder cattle producer or feeder calf producer from the southeast, this definitely limits supply going forward. As as they just mentioned, you get to this wide part of Mexico. If they lose control now in July, when it's warm, it's wet in that area, this problem could spread a lot more, and we'll see. But on the supply side of things, just tighter supplies for feeder calves in the United States. So there's for every producer out there, it's going to mean a little something different depending on which side of the border you're on.
And how does the border closure help with the prevention of or the mitigation of the problem with the screwworm?
I think we brought up that the lack of movement of livestock that certainly helps it just in terms of a kind of a numbers scenario, but this is not a fly pest that is unique to just livestock. We can control the flow of cattle across the border, but it would be an impossible task to try to monitor every type of wildlife that would be moving naturally across that border. And with a relatively wide range of hosts that this fly can use, that it certainly limits the chances of incursions through livestock, but it doesn't negate it entirely because of that wildlife aspect of it.
The one thing, we just hit on wildlife. I guess I think just of the history of what screwworm did to Texas previously, where they lost somewhere between 40 to 80% of their white-tailed deer population during the 60s. Not saying anything like that happens this time, but that is the area for concern wherever we think about what the impact could be to livestock, or even I think about it on the cattle side where they are on some very open range in western United States. That's just a cause for concern. Is that kind of going through y'all's minds as well?
Yes. And, there's another aspect of this that I think is one of the biggest unknowns is we're talking about the 1960s when we were managing this pest. The United States, in terms of how we use our land, in terms of urbanization, in terms of the population, in terms of just everything, every aspect of life in the United States is very different than it was in the 60s. And so the way we handle how this pest behaves in a modern United States, that's a huge question mark. What this fly is going to do, where it's going to spread, how it's going to affect things, all those challenges. I think there are unique aspects of 2025 that we are going to find that they never had to deal with in the 60s. And that's going to be one of the major challenges in an already challenging pest to control.
The good things about the screwworm is it was such a major pest. It's very well documented what it did to the industry in across Texas and Florida, back in the original 40s, 50s, 60s. And so in Florida, basically 70 to 80% of all wounds in livestock were infected. So it's a major pest. It's not just like a sometimes thing. If you had a wound on an animal, it was very likely that it was going to get infected. So that's kind of the bad news side of things. I think the good news side of things is compared to the 60s, we do know a lot more. We have a lot more tools available now that we did not have then. And so, as Ted was saying, there's a lot of dynamics that may have shifted that could have kind of caused more alarm or concern for what an outbreak today might look like. But on the flip side, we have more tools now than we had then to fight the outbreak. So hopefully that will provide some mitigation to kind of worst case scenarios that could occur.
So I want to understand a little bit more of the impact on the ground and how, first of all, how we identify, and when you identify the problem, what's the next step? With the understanding that it is not here yet,
Correct,
but could be potentially coming.
Well, I can start off on that. It was one of the big discoveries that led to the sterile insect technique being so successful, is that unfortunately this fly, it's a shiny green fly, the same kind of, general look that you see on any green shiny fly in your backyard or flying around a dumpster. And there are a lot of species of flies that look very similar to a screwworm fly. It was the identification of a morphological feature that enabled them to separate out what that fly looks like. That is, in terms of like a larval identification, the unique thing there is that they're going to be in a live animal, whereas larvae that are in roadkill or something are not going to be screwworm. That's an important fact to also get out, is that New World screwworm do not utilize roadkill or any dead animals. The larvae die very quickly once an animal dies.
Only fresh flesh.
Only
living
live flesh,
only
yes.
living flesh.
So this is not going to be a fly that's going to be complicate control strategies, because every dead animal on the side of the road is going to be potential for females to lay eggs on and generate more flies. That is not a thing that happens with this fly.
I think, following up on that point, I think so it is true, absolutely true, that these flies are not going to lay eggs on a dead animal, and some young larvae in that dead animal are going to die when the animal dies. But I think one thing to remind, if the larvae are already like 5 days in, 6 days into a 7-day life cycle, and that animal dies, they're still going to be able to get out and survive. And so if you suspect an infection in a living animal, it's really, really important not to move it anywhere. Don't take it to the vet. You want to contact your veterinarian immediately, but do not take the animal someplace else. Don't move the dead animals that might be infected, because they still should be shedding larvae. If you're then moving the animal around, is this going to spread that outbreak around further? So it's really important to find out what's going on immediately and not move those animals anywhere, even if they happen to die.
Who is the contact that we need to? So if you don't work with a vet directly.
Absolutely. So that's going to differ by state. So here in Florida, the primary contact is going to be FDACS, and right now the Division of Animal Industry. I know they have a hotline set up, and you should if you suspect screwworm, you should call that hotline immediately, and or you're obviously the veterinarian as well. But there is an FDACS hotline, and FDACS has a New World screwworm kind of info page that has more information about how to manage things. In other states, it's going to vary. I know that in Oklahoma and Texas, they're putting together kits that they're sending out for people if they suspect larvae, to send them in after they've been killed in ethanol and things like that. But it's really going to vary by state. Here in Florida, there's an FDACS hotline.
So if you want to find more information about this, you can check the description of this podcast. We will put some of those links and contact info. But pretty much the hotline has a number here. It's 850-900, or also via email, or rad@fdax.gov. But we can also facilitate, if you want to contact us, we can facilitate this. Important thing is to, first of all, do not move. Second, treat. And then right away contact the vet or the FDACS directly.
Yeah, I think, keep in mind, as Ted was saying earlier, like these larvae they complete their life cycle on the animal in 7 days, right? Right now where we're at. So like, you can't wait like a week. Like if you wait a week, that they're already flying around infecting other things, right? So you have to really make sure that you, as soon as you see a case of myiasis, like a wound that might have living maggots in it, you have to act immediately.
A couple of other points there to add to define myiasis. That's an entomological term. It's just a fancy word for fly larvae colonizing the living tissue of an animal. The second part that I was going to say about this is you're going to likely find, if you're going to find this in an infestation of New World screwworm, it's going to be larvae that are in your animals. Adult New World screwworms are not like horn flies or stable flies or house flies or eye gnats, where you're going to have clouds and clouds and clouds of them around your animals. In traps, you may have one single screwworm fly in a trap of 10,000 other similar looking flies. They are not a extremely densely aggregating type of fly like a horn fly or a stable fly. So that's another thing to point out, that most people and trained entomologists aren't going to be able to look at a single adult fly sitting on a fence post and say that's a New World screwworm fly, because they look so similar to so many other shiny green flies. The way it's going to be spotted is through that myiasis, or that larval colonization of your animals.
We're specifically looking for, we're keeping an eye on any animal that has any wound. That's where or also right after birth, right?
Any open wound, yes. So any tissue damage that is done post birth, the umbilical, anything around the female's genitalia, there can be a lot of open wounds or small lacerations or things like that. Dehorning efforts, even small wounds that are caused by dehorning efforts. When a tick falls off, the little open wound from a tick bite is been shown to be enough for colonization to start. In rarer cases, they will also lay eggs around mucus, like around the nostrils and things like that, to get into the animals. So, but the primary way we see it get in is usually from some kind of wound. That's how much do you actually look at your animals, very carefully and see little tiny wounds, or how do you detect, things like tick bite wounds? It's a really insidious process that these flies use, and it's very hard to even manage. A lot of times I hear, well, if we could just manage wounds on our animals, well, that's a really, really, really tall task to ask for, and that's why that's not really a recommended strategy.
Back home, we have a lot of problem with sheep, especially when the lacrimal canal here and starts getting more, like for example, tall grass, and they start having mucus or any secretion there, and that's where they lay the eggs. And very, very short period of time, that whole half of the head is pretty much gone.
Yep.
One important thing is this is an evolving issue. So we're recording this on July 10th, but if you listen to this later on, things have going to be changing pretty quickly here.
Yeah, I was going to say wait a week, and then we'll have new cases somewhere slightly different in Mexico. I mean, I think is when it's where we've come since November. I mean, Screwworms made a lot of progress, but it's now, early mid-July. This isn't necessarily just a 2025 issue, is kind of what I wanted your thoughts on moving forward. Is this something you're kind of thinking about? Think about it for 2026, 2027.
100%. And actually, I thank you for bringing that up, because I think that's really something that's important. Like this, even if we can stop it today, like even if here on July 10th, it's not going to spread anywhere close to the border. This is going to take years to put back in the bottle. Like this is going to take years and years of effort to get back down through South America, back to the Panama, Colombia, right? We're going to be in a position of vigilance for at minimum the next 5 years, minimum. And it's going to take at least that. I mean, I don't want to speculate, but looking at this fly production and doing the math on how long it takes to ramp up and how long it took, we've done that. We did this before. Like we know how long it took the first time. And if you look at the numbers there, I mean, it took years. It took years and years. So this is not something that is going to be like, okay, mission accomplished. We did it at the end of 2025. Even if we are successful at not having it come into the U.S., we are going to have to be on a defensive posture for at least 5 years and probably longer. So I think that's the important thing here to keep in mind. This is going to be this is a long-term play. I mean, where it's a short-term emergency response, hopefully, that we can get under control. But this is going to be a long-term issue for a while.
We had one of just a few cases in Florida back in 2017 where they have thousands across Mexico right now. So, yep.
Well, yeah, I mean, it took 6 months. I mean, there was, a couple of tiny islands in Mexico took, I think, 6 to 8 months of like constant eradication effort on like a best case scenario. When you talk about moving into like continental Mexico, I mean, it's really obviously USDA and everyone's taking it very seriously, and we're spending a lot of effort and energy on it right now, and that is excellent. But if we just look at past history, it just suggests that we're in this for a long haul right now. And we need to be positioned for a long-term response, not just a 2025 response.
Absolutely.
Very well.
But I think one thing that we haven't really touched on is the monitoring in terms of non-animal monitoring. And I think that gets talking. The main way we monitor for screwworm now is through actually cases of screwworm, like in animals. So we're, wounds are, we're monitoring livestock, monitoring wildlife. We find cases. And what we really want to move towards is having a much better and robust early detection system where we are not having to, where we're not like, oh, it's already in this animal in this place, which means the flies already were there and flying around and it's probably infecting other animals. Like, we want to have a much earlier, much more proactive monitoring mechanism. And I think that's where I know there's some research going on, and we're working on some things here at UF on this area, that we can really have better remote sensing monitoring, better trapping mechanisms, so that we can actually deploy these in border areas, or, whether that's the state of Florida or in Mexico or wherever, so that we can have more monitoring, more robust monitoring in rural areas and rugged areas where maybe there aren't cattle moving around, we're looking at all the time. I think that's really where that's a technology we really need to be investing in a lot right now.
That goes back to something we talked about previously about we do, the landscape of the U.S. and our livestock production systems do look, very different than they do from the 60s. But combined with that, we do have extremely powerful tools available to us that they never had back then. We have spanned the molecular biology revolution in the time that this was being eradicated, and we have those types of tools available to us now that we never had back then. And that also enables us to do some really nice types of passive surveillance using environmental DNA samples and things where we don't have to always lure the fly to a trap. This is not a highly abundant fly, so it's hard to do surveillance on adults unless you have technologies that either aid in bringing in adults or can screen higher numbers of adults, because the human labor aspect of this becomes pretty onerous. So being able to do much more passive, wider geographic range, surveillance is something that we have in the toolbox now. And yes, at UF, we're developing a lot of types of technologies that could be deployed towards this problem.
Fantastic. So hopefully we can continue this discussion, but hopefully it would be on a more positive tone and not updating more issues. I think we're still in time to make a lot of mitigation progress yet and not let it come. But appreciate both of you coming today.
Thanks for having us.
Yeah, it was great.
Thank you for joining us on this Cow Talks podcast. We hope you have enjoyed this conversation.
If you have any questions, ideas, follow-ups, or comments, please reach out to us through our email, forages@ifas.ufl.edu. That is forages@ifas.ufl.edu. Or find us on our social media, uf.forages on Instagram, UF Forage Team on Facebook, or UF IFAS Forages on YouTube. Cow Talk Podcast was brought to you by the University of Florida Forage Team with technical support from the University of Florida College of Agriculture and Life Sciences Faculty Instructional Resource and Support Team. This episode was produced by Marcelo Valao, Olivia Maule, and Ashley Kanabrowski.